Hello dear students, so today I am going to explain a very interesting concept that might help you in preparation for JEE Advanced and Olympiad. So this is a concept of bungee jumping. So bungee jumping is an adventurous sport in which a person jump from a high platform while connected with an elastic cord. At the same time, this sport is a very dangerous one. I will never dare to try this in my entire life. But I found this very interesting video on the internet where this young lady is performing this stunt. She is so brave and confident at the same time. So basically, before I explain this concept, you must watch this video, and then it will be easy for me to make you understand what is actually the concept of the bungee jumping. So students, now we come to the problem of bungee jumping. What is the statement of the problem? A girl of height h is equal to 2 meters, as you saw in the video, is bungee jumping from a platform situated at a height of 25 meters above the lake. One end of an elastic rope is attached to her foot and the other end is fixed to the platform. You all have experienced this, everything in that video. Okay, so everything, whatever is written here, you have already seen that, so that you can clearly imagine what kind of situation we are dealing here. She start falling from the rest in a vertical position. The length and elastic properties of the rope are chosen so that her speed will have been reduced to zero at the instant when her head reaches the surface of the water. Ultimately, she is hanging from the rope with her head 8 meters above the water. Find the unstressed length, maximum speed and the maximum acceleration of her during the jump. So basically बच्चों यहाँ पे क्या दे रखा है, एक गर्ल है जिसकी हाइट 2 मीटर दे रखी है, प्लेटफॉर्म बच्चों 25 मीटर ऊपर है लेक से, और ये इसका पैर जो है बच्चों एक इलास्टिक रोप से बंधा हुआ है, और रोप की लेंथ इस तरीके से एडजस्ट की गई है कि when her head touches the water of the lake, the velocity of the girl is 0. So we have to find the unstressed length of the string, her maximum speed during the jump and her maximum acceleration. So bungee jumping का जो basically पूरा का पूरा फिनोमेना है बच्चों, इसमें उससे रिलेटेड जितने भी क्वेश्चन बन सकते थे सारे के सारे क्वेश्चन हमसे पूछ लिए गए. So this is kind of an olympiad question as well. So बच्चों, इस वाले क्वेश्चन को सॉल्व करने से पहले थोड़े से हमें डायग्राम बनाने पड़ेंगे ताकि आप लोग इसको और अच्छे से समझ सको. So let's say कि this is the platform, और जिस प्लेटफॉर्म की जो हाइट है बच्चों ये 25 मीटर के बराबर दे रखी है. यहां पे जो पर्सन है, whoever is jumping, he or she is there. So इसके पैरों को रस्सी से बांध रखा है, जिस रस्सी का एक एंड जो है यहां पे इस तरीके से अटैच कर रखा है. When her head touches the lake water, she is like this and the rope is like this. So rope is something like this. Okay, so her foot is attached to the rope. The height of the girl is 2 meters. We are considering here 2 meter height. So she was standing here when she was 2 meters tall. Okay, so something like this is happening. So this is the initial position, this is the final position. And when she settled, her head is 8 meters above the water surface. So when she stopped moving, at that time this height is given as 8 meters. So height of the girl from the lake water is, head of the girl is 8 meters. Okay, so what will be this remaining length? So this remaining length will be equal to this was total was 25 meters na, so it will be 17 meters. So 2 meters is the girl's height, so the string length will be equal to 15 meters. So at the time when the girl is at rest, the length of the string is 15 meter. So this is happening here. Okay, all the data I have written here. So basically हम इस क्वेश्चन को जब सॉल्व करेंगे तो what we will consider, the center of mass of the girl will be at 1 meter height from the platform. Okay, and when her head touches the water, the center of mass of the girl will be 1 meter above the water surface. Okay, so it will be 1 meter above the water surface. So what height her center of mass has descended, that will be equal to 25 meter. Okay, so 25 meter is the height descended by the girl's center of mass. Okay. So here the velocity of the girl is 0, and here also the velocity is 0. When she start jumping, the velocity is 0. So basically, when she reaches at this point, the gravitational potential energy decreases. That gravitational potential energy is converted into the kinetic energy, and some energy goes to the string. But when she stops here, the whole gravitational potential energy is converted into the elastic potential energy of the string. Let's consider the length of string. Natural length of the string is L naught. So what will be the extension till this point? That will be 25 minus ka L naught. No, it will not be 25 minus ka L naught. So basically, in the end, girl's foot will be 2 meters above the lake. So girl's foot will be 2 meters above the lake. So string will be of this length. So it will be equal to 23 meters. So extension in the string will be, at that moment, extension will be equal to 23 minus ka L naught. So 23 minus ka L naught will be the extension in the string when girl stop at the while her head touching the water surface. So now we start solving this question. So we can clearly see the gravitational potential energy, which is equal to m into g into 25. M into g into 25. 25 meter her center of gravity descended. That is equal to half k into 23 minus ka L naught ka square. The whole gravitational loss in the gravitational potential energy is converted into the elastic potential energy of the string. Okay. So when she is hanging here, her head is 8. When she is at rest, when the string force is balancing her weight, her head is 8 meters above. Her head is 8 meters above the water surface, and her leg will be 10 meters above the water surface. So what will be the length of the string here? That will be 15 meter. 8 meter, and this will be 15 meter. So extension in the string will be 15 minus ka L naught, and that because of that extension, the weight of the girl is being balanced. So mg is equal to k into 15 minus ka L naught. This is the extension when C is at rest. Okay. Now what we do, we take this value, we divide both, and 25 into 15 minus ka L naught will be equal to, this 2 also comes on this side. This will be equal to 23 minus ka L naught ka square. Okay. Something like this we get. So either we make a quadratic equation, we find the root, but I can see one thing here. It will be 50. So here on this side it is 50, and it is 23 minus ka L naught. So value of L naught should be less than 15. And there is a very odd type of number, 23. Here 0 will be coming. I am trying to solve it by a shortcut. Okay. I am not going into the solving into the this quadratic equation. So I can choose some value of L naught. So here it is 23, and value of L naught should be less than 15. So I will take first value as 13. If I take L naught is equal to 13, so it will be 2 into 2, 4 into 25, it will be 100. And 23 minus ka 13, it will be 10 ka square. Yeah. So value of L naught will be equal to 13 meter. And I got it directly. When I saw this 23 at the same time my mind started thinking about considering this value. Okay. So basically the natural length of the string is 13 meter. 13 meter is the natural length of the string. And so this is when C is hanging here, the length of the string is 15 meters. So the extension at that time is 2 meter. So K into 2 is equal to M into G. This is one more relation we are getting here. Okay. So what else we have to find? We have already find the unstressed length. We have to find the maximum speed. So the maximum speed will be at this position only. At what position? Where the net force on the girl will be equal to 0. At that position, her speed will be maximum. Her speed will be maximum at that position. So where is the net force on her 0? When extension is 2 meter. So at that, to find the maximum speed, what we will do, when her center of mass is at what depth, like below what height below this. So basically it is 15 meter and center of mass will be here 16 meter, and center of mass was initially at 1 meter above. So center of mass has descended 17 meter. So m into g into 17, this is the gravitational potential energy that it has lost, minus ka half k into 2 ka square, and this should be equal to half m into v max ka square. So from here we get the maximum speed. K into 2 is equal to mg. So we will put this as mg. So mg into 17 minus ka mg into here it is 2. So it goes like this. So it is k into 2. So this is mg. So 16 m into g is equal to half m into v max ka square. So m gets cancelled out. So v max from here we get. So maximum v max from here we get is equal to 320 meter per second. This is the maximum speed of the girl during the motion. And when this maximum speed will come? When her acceleration is equal to 0. Are you able to understand this till now? Okay. So there were like this is a really good question actually. Now we talk about the maximum. Now we talk about the maximum acceleration of her. So when there is an extension of 2 meter, the force by the spring is equal to mg. Okay. The force by the string is equal to mg. So when she start falling from here, the acceleration is g. When string is slack, the acceleration of her is g. So once there is extension in the string, the acceleration will reduce. So acceleration first will reduce. When there is an extension of 2 meter, the acceleration will be equal to 0. And as she descend, because of the velocity she has attained, her acceleration will be now upward because the kx will be more. So what is the, basically c is going 25 meter below. So 23 meter is the final length of the string, because 2 meter is the height of the girl. 23 meter is the final length of the string. And out of that 23, 13 meter is the natural length. So 10 meter is the extension in the string when c is at the lowest point. Okay. So when c is at the lowest point, the force acting is k into 10 and downward it is mg. So k into 10 is basically equal to 5 mg. So at the lowest position, the 5 mg force will be acting upward, velocity will be 0 here, mg is acting downward, so acceleration will be equal to, maximum acceleration will be at the lowest position, and that will be equal to 4g. So the answer of the third part is the maximum acceleration she got at lowest position, and that is equal to A max is equal to 4 m into g. The video we have used in the while explaining the question is of a girl. She is very brave. I can see, you all can see her facial expressions, and she is very brave and confident at the same time. I am hell scared of this bungee jumping sport. So I'm never going to try it. But when I saw her, I thought of explaining this question. You all must understand the physics behind the bungee jumping. And I hope the concept of this question is very, very clear to all of you. And this is a very, very important question for JEE Advanced and the Olympiad. Thank you. We will we'll see you in the next question. That question is going to be more amazing than this one. Thank you. Bye-bye. Take care.